AI just got a major upgrade on every front. Google DeepMind just cracked a major flaw in how chatbots think. Now, instead of being fooled by flashy nonsense, they are finally learning to focus on truth, logic, and what really matters. Over in China, researchers turned a weak math model into a reasoning machine that can go head-to-head with some of the smartest AI out there. Meanwhile, Meta just launched $1 billion AI super team pack with talent from OpenAI, DeepMind, and Anthropic. Microsoft, they built a medical AI system that diagnoses patients 4 times better than human doctors. Seriously. And if that wasn't enough, Xiaomi just dropped smart glasses that blow Meta's Ray-Bans out of the water with voice control, real-time translation, and even pay-by-glance tech. Yeah, it's been a wild week in AI. Let's break it all down. Alright, let's start with a big fix from DeepMind. Chrome fixes chatbot judgment. Google DeepMind. You know how AI models are trained to give answers we like? They use something called a reward model to figure out what's good. But the problem is these reward models often get it wrong. They might give a high score just because an answer is longer or sounds nice or uses fancy formatting, even if it's not actually accurate or useful. To fix that, DeepMind teamed up with researchers from McGill University and MA and built a new system called Chrome. It stands for Causally Robust Reward Modeling. But what really matters is how it works. Instead of just training the model on random examples, they taught it the difference between what really makes an answer good, like being factual or logical, and what just looks good on the surface, like being polite or long-winded. They did this by creating pairs of answers. Some of these pairs change something important, like whether the facts were right. Those are called causal augmentations. Others change only the style or tone without touching facts. Those are neutral augmentations. By showing the model both kinds and training it to react only when the quality really changes, the model learns to focus on the important stuff and ignore distractions. They use Gemini 2.0 No Flash to generate these examples and a high-quality dataset called Ultra Feedback to guide the process with real human opinions. To test it all, they tried this on 3 different language models: Gemma 2.9 billion, Quinn 2.57 billion, and a smaller Gemma 2.2 billion, and ran it through a few challenges. One called Reward Bench to see how well it ranks answers, another called Reword Bench that adds sneaky distractions to test focus, and a third called Wild Guard Test to check how safe the model is when answering dangerous or harmful prompts. The results: Chrome made the models more accurate, especially in areas like safety up by about 13%, and reasoning up by around 7%. Even when the test tried to fool the model with tricky styling, Chrome still held up better than the usual reward models. And when they gave it multiple answers to choose from, Chrome was better at avoiding harmful content without becoming overly cautious. So, what's the big takeaway? Chrome teaches AI to focus on what really matters in an answer and ignore the fluff. And that could make future chatbots a lot more helpful, honest, and safe. All right. Now, remember when self-driving cars felt like sci-fi back in 2019? Now over 400,000 Teslas drive themselves every single day. And while no one was paying attention, AI adoption exploded by 270% in just 3 years. Companies once skeptical are now 15% more productive than their competitors. McKinsey predicts AI will add $13 trillion to the global economy by 2030, but also force 375 million people to switch careers, and those roles will demand serious AI skills. Now, while Google DeepMind focus on making AI answers more aligned with human values, researchers at Shanghai Xiaolong to Think Boost AI Math Reasoning University went after something else: raw thinking power. They wanted models that can handle tough problems, especially math, using proper step-by-step reasoning, or what's often called chain of thought. We already know that some models like DeepSeek R10 and SimpleIL got a boost from reinforcement learning when you train them to think in steps. That trick worked well on the Quen family of models. But when they tried it on models from the Llama family, things got weird. Instead of getting smarter, Llama's answers just got super long, up to 4,000 tokens, without actually becoming more accurate. So, the team figured the real problem wasn't the reinforcement learning itself. It was how the base model had been trained before that. Their fix: a 2-phase training plan they call Stable Then Decay. In the first phase, they trained the model on 200 billion tokens of high-quality math data from a mix called MegaMath Web Pro. Once that training levels out, they split the model into 3 branches and continue training, each with different types of math and reasoning questions, about 20 billion tokens per branch. They called the new model family Octoinka since each version focuses on a different kind of thinking. The long branch keeps all the detailed reasoning steps. The short branch trims it down, and the hybrid finds a middle ground. It's like giving the model 3 different study styles and seeing which one performs best. They tested all 3 versions on a bunch of well-known math benchmarks: GSM-8K, Math 500, Olympia Bench, and even the American Math Competition from 2023. And across the board, every Octoinka version outperformed the original Llama model by at least 10%. The long version even matched Quen performance, which is impressive because Quen is already known for being really good at step-by-step reasoning. The biggest win, Octoinka, didn't fall into that long and messy answer trap. Its answers stayed clean and focused, while regular Llama just rambled on when put through reinforcement learning. The researchers say this shows that if you train the base model the right way first, reinforcement learning can build on top of that and actually improve performance instead of just making things noisier. Looking ahead, they want to expand Octoinka with even more advanced abilities like plugging in scratchpad tools or math checkers. And they are pushing for larger, cleaner math datasets since most of the current ones are still under 100 billion tokens. The goal is to build models that are ready for smart reasoning right out of the box without needing extra patchwork training later. Now, news of smarter models Meta builds AI superintelligence team naturally turns into a hiring frenzy, and Meta is racing hard to catch up. Mark Zuckerberg just announced Meta Superintelligence Labs in an internal memo made public by reporters. The freshly minted group folds all of Meta's frontier AI work under one roof, and the company spent a multi-billion-dollar package to lure Alexander Wang away from Scale AI and hand him the Chief AI Officer badge. Former GitHub Chief Executive Nat Friedman joins as a partner, and 11 other senior researchers from Anthropic, Google DeepMind, OpenAI, and similar shops signed on after receiving offers rumored to sit well inside the 8-figure range. Meta also sniffed around acquisitions of Mira Murati's Thinking Machines Lab, the search engine startup Perplexity, and Ilya Sutskever's safe superintelligence venture, though none of those talks reached the binding offer stage. Inside the memo, Zuckerberg says the lab will start research on our next generation of models to get to the frontier in the next year or so, signaling that Meta wants to leapfrog rather than merely match the state of the art. Given the talent arms race, a lab stocked with Anthropic and XDeepMinds makes Meta's comeback bid look serious. Microsoft, for its part, chose Medicine Microsoft AI outperforms human doctors as a proving ground for multi-agent coordination. Mustafa Sullian's AI division unveiled the MAI Diagnostic Orchestrator, nicknamed MAI DXO, and called it a tangible step toward medical superintelligence. The orchestrator works like a debate panel. It queries several foundation models: OpenAI, GPT, Google, Gemini, Anthropic, Claude, Meta, Llama, and XAI, Grok, then blends their answers into a single plan. The team pulled 304 real case studies from the New England Journal of Medicine and built the sequential diagnosis benchmark, which walks through the classic clinical sequence: note symptoms, decide which tests to order, evaluate results, repeat until a diagnosis clicks. On those cases, Midaxo reached roughly 80% diagnostic accuracy, 4 times better than a panel of human doctors barred from consulting external references. Better yet, the orchestrator trimmed cost by about 105 because it tended to pick cheaper scans and blood panels when possible. MIT's David Sontag and Scripps researchers Eric Topol praised the study's rigor, but warned that true proof needs a live clinical trial where physicians and AI tackle real patients head-to-head. Microsoft has not set commercialization plans in stone. Yet, insiders hint at Bing integration for consumer self-triage and professional tools that could automate parts of patient workup. To build the system, the company quietly poached several high-profile researchers from Google, underscoring how hot the talent market has become. Hardware is not sitting still either at the Human Car Home Showcase in Beijing. Xiaomi smart glasses with AI features enter the smart glasses arena with a pair that leans on an in-house assistant called Super Shia AI. Under the hood sits a Qualcomm AR1 chip plus a Hang Swan 2700 coprocessor. A 12-megapixel ultra-wide camera lets wearers snap photos or shoot first-person video. And the glasses can translate text or identify objects in real time. You can even confirm an Alipay purchase with nothing more than a glance and a voice confirmation. The battery measures 263 milliamp hours and promises 8.6 hours of use, dwarfing the Ray-Ban Meta collaboration that tops out near 4 hours on a much smaller cell. Sound comes through open-ear stereo speakers and 5 microphones handle voice commands. The frames weigh 40 g and carry an IP54 splash resistance rating. Arms pivot 12 degrees outward and tilt 5 degrees forward, a geometry tuned for typical Asian facial contour. Electrochromic lenses darken in about 0.2 of a second when you double-tap the temple. And color choices span classic black, parrot green, and translucent tortoiseshell brown. Price lands at roughly 1,999 yuan, around $280 United States dollars, for the base model, rising to 3,000 yuan, about $420 if you want color-shifting lenses. Compared with Meta's stylish but short-lived Ray-Bans, Xiaomi offers twice the endurance, voice-first controls, and a pay-me glance party trick, though the company hints that the first release is aimed at the domestic market rather than an immediate global rollout. So now the question is, will all of this actually make AI more useful or just more powerful? Let me know what you think in the comments. Don't forget to subscribe and drop a like if you found this interesting. Thanks for watching.